We've been watching Saturn for centuries. Galileo saw it first, a blurry shape with strange ears, the earliest human glimpse of its rings. Later, with clearer lenses and better telescopes, we came to know it as the jewel of the solar system. Mysterious, massive, beautiful beyond belief. But now, in the 21st century, with spacecraft orbiting beyond the asteroid belt and telescopes that see in invisible wavelengths, Saturn is becoming something else entirely: unpredictable. It's easy to assume that a gas giant is static, its rings unmoving, its clouds just swirling patterns. But that illusion is breaking. The more closely we observe, the more we realize Saturn isn't still. It's changing, reacting, evolving, and some of those changes are just plain strange. This isn't just a gas ball with a pretty face. Saturn is doing something new, something bizarre, and the deeper we look, the more the mystery grows. At nearly 95 times the mass of Earth, Saturn is a true giant, a planet so large it could hold every other world in the solar system except Jupiter. And yet, for all that scale, it remains elusive. Its outer layer is mostly hydrogen and helium, but beneath that is a cocktail of trace gases and complex molecules. Deeper still, pressures rise. Hydrogen becomes liquid, and in the heart of Saturn, hydrogen may become metallic, an exotic state of matter that could generate the planet's powerful magnetic field. And this field is key, because it connects the surface we see, those elegant clouds and bands, with the deep, unseen engine beneath. It's the thread that ties Saturn's atmosphere, auroras, and perhaps even its core into one dynamic system. When we see a storm on Saturn's surface or an aurora ripple across its poles, we're not just looking at weather. We're witnessing a global conversation, a planetary system speaking through light, magnetism, and heat. On Earth, auroras are born from the solar wind, charged particles funneled down by our magnetic field into the upper atmosphere. They glow green, red, even purple, dancing across polar skies. Predictable, beautiful, understood. But Saturn's auroras? There's something else. For years, scientists assumed Saturn's auroras worked the same way: solar wind interactions with a magnetic field. But observations have shattered that model. Some of Saturn's auroras flicker even when the solar wind is calm. Others seem to pulse in ways that don't match anything we've seen before. Some auroral displays have been spotted far above the atmosphere, at altitudes that defy explanation. Others appear to be tied not to solar activity, but to events happening deep within Saturn itself. How can an aurora be born from inside a planet? That's the question scientists are now racing to answer. Because Saturn's auroras may not just be surface phenomena, they might be signs of deeper disturbances, tremors in a world we barely understand. In 2023, astronomers noticed something odd: a spiraling cloud formation in Saturn's mid-latitudes. It wasn't part of a regular band, nor linked to one of Saturn's many storms. It stood out, hotter, brighter in the infrared, and completely unexpected. Then it disappeared, gone in days, and another appeared elsewhere, this time forming a bizarre hexagonal pattern like the famous North Pole vortex, but far from the pole. These features aren't just unusual, they break the models. They're not storms in the traditional sense. They don't behave like Earth's cyclones or Jupiter's Great Red Spot. They seem to form spontaneously, perhaps triggered by deep convective upwellings or magnetic disturbances. And it's not just the shape or motion that's strange. These anomalies are hot, emitting more infrared radiation than the surrounding atmosphere. Some even appear to be emitting unexpected chemicals, including complex hydrocarbons that suggest extreme electrical activity or unseen reactions in the upper layers of the atmosphere. It's as though Saturn is cracking open, just slightly, and letting us peek at something deeper and stranger than we imagined. Saturn's magnetic field is supposed to be simple, nearly perfect. Its north and south poles are almost exactly aligned with its spin, unlike any other major planet. That should mean a stable, predictable magnetic field. But nothing about Saturn has turned out to be predictable. Data from Cassini hinted at this. Strange magnetic anomalies, drifts in the field, changes over time. At first, scientists thought it might be observational error. But now, new observations, including Hubble and ground-based magnetometers, suggest something more profound. Saturn's magnetic field is shifting, not just in strength, but in structure. Some regions are weakening. Others are fluctuating in ways we don't yet understand. It's as if something deep inside the planet is stirring, a churning dynamo responding to slow, planetary-scale movements. This could be tied to the auroras, to the strange clouds, even to Saturn's weather. Because on a world so massive and fluid, magnetism isn't a separate system. It's part of the whole. And if Saturn's field is changing, the entire planet could be changing with it. The Cassini mission was a triumph of human engineering. 13 years orbiting Saturn, sending back over 450,000 images, diving between the rings, and finally plunging into the atmosphere in a fiery end. It transformed our understanding of the Saturnian system. But Cassini also left behind puzzles. Its instruments detected massive differences in Saturn's gravitational field that hinted at unknown internal structures. It spotted lightning storms unlike anything on Earth. And its final dives revealed an unexpected rain of material from the rings, drifting into the planet in a steady shower. Now, with Saturn revealing new behaviors, it's clear we need to return, not just to visit, but to listen, to send instruments designed to probe Saturn's magnetic field with unprecedented precision, to launch orbiters that can track atmospheric changes in real time, to deploy atmospheric probes that can survive long enough to measure these bizarre new features up close. Because whatever Saturn is doing, it's doing it now, and we may never get another chance to catch it in the act. Saturn is now one of the most closely watched planets in the solar system, and not just because of its beauty. Telescopes across the world and above it are watching. The James Webb Space Telescope has begun peering at Saturn in wavelengths never before used on the planet. Radio arrays monitor its magnetic emissions. Even amateur astronomers, equipped with modern optics, are capturing changes in its atmosphere. In the coming years, the Vera Rubin Observatory will survey the outer planets regularly. Next-generation probes are being proposed, some designed to orbit Saturn for decades, others to land on its moons, where signs of life might also be found. But Saturn itself is now a target of urgency, not just wonder, because it may be teaching us something important, not just about gas giants, but about the hidden dynamics of planetary systems. And in a universe where gas giants are the most common type of planet, understanding Saturn may be key to understanding hundreds of worlds beyond our own. Saturn has always been a paradox, a planet of perfect rings and impossible storms, a place of calm symmetry, masking chaotic energy. But these new discoveries, the strange auroras, the bizarre clouds, the shifting magnetism, are a wake-up call. They tell us that Saturn isn't done speaking. It may, in fact, just be clearing its throat. In its swirling skies and glowing poles, Saturn offers us a message that even in systems we think we understand, there are still revolutions waiting beneath the surface. And that beauty is not the end of the story. It's the beginning of curiosity.